Vitess is a framework. We could call it a middleware between your data store and the application. And it has some massive important features like query serving, cluster management, and a thing called V replication. We call it a Vitess replication. So with all of that, it can do the sharded MySQL or unsharded. It can scale. Technically speaking, it can scale unlimited. You can scale as much as your cloud or your hardware scales. So there's no limit to scaling. It provides high availability, built-in high availability, and it actually has all these algorithms and the consensus algorithms built into the how it behaves. And it's also cloud native. You can take it from one cloud to the other cloud, or you could actually co-orchestrate between the other clouds. So that's more advanced implementation of Vitess. So all of that, you could do that in Kubernetes. What exactly is Vitess? Is basically Vitess is a MySQL driver. Basically, it has everything that the MySQL has. The ACID compliance. It provides MySQL 5.7 to 8x compatibility. It has its own control plane, built-in utilities, or open source utilities that are actually used commonly in the market. And it's also open source project that has multiple contributors, both from PlanetScale and outside of PlanetScale, and the users of Vitess are also contributors. So basically, it was a project that was released by Google to the open source community under Cloud Native Computing Foundation, and it's being open sourced. So it is a project that's run as an open source, and there's no intention to change that, and it's not possible to do that within the current licensing. So it's an open source project which is open to public. You could open issues, pull requests, and ask for help for that project. So that's where it's at. We look at that architecture. So basically, if we just take our MySQL piece out of it, it actually comes with the components that are actually suitable for Kubernetes environment also. This you can do that on a non-Kubernetes implementation, but the components of the Vitess architecture, basically you could just take out of the batch and put it on Kubernetes without thinking, right? So we said about query serving, we actually have the load balancer, and that actually drives traffic to the VT gate. VT gate is the query serving engine for the Vitess. And then it actually has a topo server if you have a sharded environment, that it knows where your data is, where your data is actually distributed. And the other components actually built into that control plane that actually drives all these utilities and internal resources that actually route your traffic from application server to the load balancer to the Vitess environment, and then from that on, it actually manages the data. And interestingly, you can do all of that inside the Kubernetes also, which lets you break it up into Vitess concepts that actually placed into the pods of those smaller containers. So,
and do you think, Alkin, someone was just asking, because from listening to a podcast from the founders of PlanetScale, having been, since the very beginning, they refer in the podcast to, Borg as a blueprint for Kubernetes. Having been inside from the very beginning, could we go so far as to say that Vitess is Kubernetes native?
Yes, we can say that. Yes, that's why it is designed. The design of the Vitess was, like I showed you, they actually came in the similar time frame, and design of the Vitess was in the mindset of Kubernetes. So I'm sure there was a lot of these, our founders, they also mentioned these. Okay, we thought about this, but because it wouldn't match the Kubernetes, mindset, we wouldn't be able to do that. So we had to find an alternate way to do things the way that it's actually in the future that'll fit.
And that's exactly it, because sometimes we find technologies where it seems that they're desperately trying to adapt to Kubernetes, but not necessarily doing things with that original mindset in place.
Right.
Perfect.
So and this mindset helps you're breaking up into the concepts of Vitess, and Vitess has its own concepts. I don't want to get into the like internals of it, but it uses tablets, key spaces, and stuff like that, which is also aligns with that, making the smaller pieces of, instead of saying an instance. In historically in databases, we would call an instance it's just one big database that actually has one or multiple schemas in it, which also one or multiple schemas drills down to the tables and the columns and the data and the rows, right? So in Vitess, because the mindset of breaking it at smaller pieces specifically for sharding, you would actually have to come up with a different concepts of key spaces and the tablets and things like v indexes, Vitess indexes, and the sequence numbers, and so on and so forth. So hopefully this is not very complex. There are some key adopters. So this Vitess, it came from originally from YouTube to Google. It's been used in that mainly to solve scaling problems of YouTube about 10 years ago, but it's also started being adopted by others. There are many other companies, there are many other logos. I'm not sure I'm allowed to actually share some of them.
Of course, yeah.
But Slack is popular right now. Everyone uses Slack. We all use Slack, and Slack has a very good story behind why they needed to adopt to Vitess type of sharding system, and they also recently blogged about it, and you can read from Slack and Vitess story. There is Square, Pinterest. There are other very well known Silicon Valley companies that actually utilizes Vitess.
But would you say that the common denominator there is the question of scaling that was found in Slack?
It is actually, that's the common theme over there. You need to be able to reach to certain scaling, and there is no other option within your topology to scale other than that, and you actually go into this way of sharding. So but basically it's the sharding. It's the answer. And how do you shard in MySQL, which it doesn't actually have a native sharding methodology within? You actually have to have an option to do that, which is in this case is Vitess. And so basically there are other adopters. You can look up how it's been implemented. But the way that I actually think about, when you say I've adopted this topology, some of these companies are very large in the case. When we say Vitess in MySQL, it could be part of their scaling or scalable architecture data store. It doesn't necessarily mean it will be done. So MySQL, we also want to highlight that is for OLTP workloads. We're not doing, analytics. We're not doing machine learning. We're not doing other things that you could do with your data in Vitess architecture. What we're doing is what we would do normally in MySQL, you would still do, because the backend engine still officially a MySQL. It's running a MySQL. So we come with all that what the MySQL provides, but you also have to live with its limitations if there is any. And also we also come up with a framework that actually drives that technology to the front end, which is the application. So application needs to adopt that. When we say, okay, we adopted to that, it doesn't necessarily mean my entire application, the whole, areas of applications are working on Vitess. That's what I wanted to highlight. And I don't think that would be a true statement even if I said so, because I don't believe that could be possible. So we don't actually take everything and drop into the MySQL in real life. Why would you do that with the Vitess? So that is my general intro, and I'm open for questions. And I wanted to also highlight over here, we'll share the slide deck, but there's a Vitess Slack channel, and you can follow the Twitter channel also. If you have questions, the best place to ask questions is the Vitess Slack channel. It's open, and you can join, and then you can ask questions. There are maintainers, there are experienced engineers from the adopters, and super smart engineers are always around to answer probably already answered questions. So that's what people come into. Like when people research these things, because they hit certain speed bump or a wall, and that's where you actually search for it. And this is a good place to ask about Slack. And I'm also there. So.